Hi, this is Victor and welcome back to my math tutoring channel. In that video, we will try to prove that integral of cosine to the power of n ax dx is equal to sine ax multiplied by cosine to the power n minus 1 ax divided by na plus n minus 1 divided by n integral of cosine n minus 2 ax dx. So I will try to prove that formula over here. So if I look at the left-hand side of that formula, which is integral of cosine to the power n ax dx, and if I look to the right-hand side, I don't have cosine to the power of n, I have cosine to the power n minus 1. So let's add n minus 1 to the left-hand side. So that integral, the integral of cosine to the power of n ax dx, I can write it cosine to the power of 1 ax times cosine to the power n minus 1 ax dx. Because I know, like, if I do x to the power of 2 times x to the power of 3, I would add the exposure, it becomes x to the power of 5. And here, because I have the same cosine ax, I can add the exposure, which is 1 plus n minus 1. It will give me cosine to the power of n ax. So as if I did not do anything here. So I know that this is equal to integral of cosine to the power n ax dx. So now, instead of writing cosine to the power of n ax dx, I will write integral of cosine to the power of 1 ax times cosine to the power n minus 1 ax dx. And if I look at that integral, it looks like I can do integration by part. Well, I can take my u equal cosine n minus 1 ax dx, ax. There is no dx here. If I take my u is equal to that, so my du is equal n minus 1 multiplied by cosine ax multiplied by the derivative of cosine ax, which is minus sine ax multiplied by minus sine ax, and I have to multiply it by the derivative of ax, the derivative of the parentheses, which is multiplied by a. So if I want to write it in a nicer way, my du, I will start with the negative that is here, I will start with it here, and then I have the a, I will put it n minus 1, and then it become cosine, sorry, I had n minus 1 here, so it become n minus 2. Because when I do the derivative of the exposure, I have to take 1 from it. So it become cosine n minus 2 ax sine ax, and that's it. This is my du. So let's highlight it. My u is equal this, and my du is equal to that. And let's take out those numbers here, those signs. Okay, and I took my u is equal to cosine n minus 1 ax dx, so I have to take my dv is equal to cosine to the power 1 ax dx. So my v would be equal to the integral of cosine ax dx. So my v is equal 1 divided by a sine ax. So let's highlight my v and my dv. So I know integration by part, the formula of integration by part, integral of u dv is equal uv minus integral of v du. And I have I have my u is equal to cosine, this is my u, cosine n minus 1 multiplied by ax, and my dv is equal cosine ax dx, which is that. So now I can replace it. It's u times v. So I can write integral of cosine to the power n ax, because it's the same thing, n, or the integral that I worked with, is equal u times v. My u is equal my u is equal to cosine n minus 1 ax times v, which is equal 1 times sine ax divided by a. So this is my u v minus v du minus integral of my v is equal sine ax divided by a, and my du is equal multiplied by minus a multiplied by n minus 1 cosine n minus 2 ax sine ax dx. Okay, let's write it in a better way. So my integral of cosine to the power of n ax dx is equal cosine n minus 1 ax sine ax divided by a. And here I know n is a constant because we said at the beginning that n is an integer greater than 1. Here n is an integer and a is a positive constant. So the n and the a are constant. So now I have minus a, and minus that is here times minus that is here, it becomes plus. And I can simplify this a with that a because I have multiplication all over. And I can take n minus 1 outside my integral since n is a constant, is an integer. So n minus 1 integral. And now I can write sine ax cosine n minus 2 ax. I can write that part. Oops. I can write that part here. So which is sine ax cosine n minus 2 ax, and I still have this sine of ax times sine of ax dx. Let's take out this. Now I have sine ax multiplied by sine ax. I have the sine ax here and the sine ax here. If I multiply them together, I would have sine square of ax. So let's write it. So my integral of cosine to the power n ax dx equal, because I want to prove it is equal sine ax cosine ax, so 2 times 3 is equal to 3 times 2. I can start with sine ax cosine n minus 1 ax divided by a plus n minus 1 integral of cosine n minus 2 ax times sine to the power of 2 ax dx. And here I can use the trigonometric identity, which said cosine square of x plus sine square of x is equal to 1. So that means sine square of x is equal 1 minus cosine square of x. And I will use it in that part. I will use it in that part, but instead of x, I have ax. So that sine square of ax become 1 minus cosine square of ax. So let's write it down. So my integral of cosine to the power n of ax dx is equal sine ax cosine n minus 1 ax divided by a plus n minus 1 integral of cosine n minus 2 ax, and instead of sine square of ax I can write 1 minus cosine square of ax, and all that times dx. Here I don't want to keep on writing that part because I will be working with this part for now. So I will copy this because I don't have a lot of spaces, and I will add whatever I highlighted in yellow at the end of my answer. So if I take what I highlighted in blue, and I can multiply cosine ax to the power n minus 2 by 1, and then minus cosine n minus 2 by cosine square of ax. So this become, I have the plus here, n minus 1 integral of cosine n minus 2 ax times 1 stays the same, minus cosine n minus 2 times cosine to the power of 2, and I have ax here and I have ax here. All that is dx. Yeah? So I have plus n minus 1 cosine, there is an integral here, n minus 2 ax. And if I multiplied cosine n minus 2 times cosine square, I have to add the exposure together. I would have cosine n of ax dx. Because of the minus here, I can have two integral, so plus n minus 1 integral of cosine n to the power n minus 2 ax minus dx minus integral, no, I have to put the n minus 1 minus n minus 1, the integral of cosine to the power of n ax dx. So if I look of what I am proving, I want to prove that in my proof here, I do have the cosine to the power n minus 2 ax dx, and I have to the cosine integral of cosine n minus 2 of ax dx. So this I will not touch, and I will work on that side of my integral. So if I take, let's write it first, n minus 1 integral of cosine n minus 2 ax dx. So I can multiply the n by cosine to the power n ax and the minus 1 by the cosine to the power n ax. But first, let's say minus n integral of cosine to the power n of ax, and minus times minus is equal to plus, plus integral of cosine to the power n ax dx. We're almost done. There is dx here. Yeah. For you to understand now, I will, because like this, I stopped copying it because I was working on whatever I highlighted on blue. So now I will copy this to give you the answer. So the integral of cosine to the power of n of ax dx equal to sine ax cosine n minus 1 ax divided by a, plus, instead of writing this part now, I will write this part here, plus n minus 1 integral of cosine to the power n minus 2 ax dx minus n integral of cosine to the power of n ax dx plus integral of cosine to the power of n of ax dx. So if I take this to the left hand side of the equality, it becomes minus cosine to the power of n ax dx, and here I have cosine to the power of n ax dx, so it's the same. Cosine to the power of n ax dx minus cosine to the power of n ax dx is equal to 0 actually. So I can bring that, I will highlight it. Now I can bring this part to the left hand side of my equation. So the minus become plus, so n integral of cosine to the power of n ax dx is equal sine ax cosine n minus 1 of ax plus n minus 1 integral of cosine n minus 2 ax dx. But I do have that n that's bothering me, because at the beginning of my equation I did not have that n, so I divide here by n, so I have to divide here by n and divide here by n. And sorry, I forgot to copy the a here. So the a here is here, and I divided by n everywhere. So now it's proven, my formula is proven. I have the integral of cosine to the power of n ax dx is equal sine ax cosine n minus 1 ax divided by na plus n minus 1 over n integral of cosine n minus 2 ax dx. If you like my video, please subscribe to my channel. That would help me tremendously. And if you put a like to that video, I would really appreciate it. Thank you for listening.